You can change your password. It just can't respond to the expired prompt that gets pushed back with you having to, there's no logic to handle that. So for this demonstration today, we're going to be using no expire as though we're setting a process ID out at the end of, going to be doing FTP connect. In your world, you might want to go ahead and set that and then have the user change it through TSO or CICS or some other means to set the password. So one of the other interesting things about the FTP server on ZOS is it does not honor trailing and leading spaces. It does embedded, right? So we could go, you know, dog, cat, bird, and those as distinct words, and it would honor that. Presuming that your client does. FTP client for MS-DOS does not. We'll be using WinSCP for that. And then there are a few characters that kind of get you. They're valid special characters for RACF, but FTP server doesn't handle them. And those two are colon and the @ sign. And if you put these into your passwords, what you'll get back is a 530 pass, login invalid password, and a pushback on it. In fact, there was just a question on RACFL this morning about this very thing. And I believe that that was the result was the person had an invalid character in their password. Okay, so if we go ahead and we just, this is, as you can tell, a RACF command. Just go ahead and I'm setting a passphrase on it. And I am setting, as I said previously, no expire, just for the purposes of the demonstration. Right, and so we'll go ahead and set it. This passphrase is 37 characters. I've got my special, I've got my upper, my lower, my numeric. No repeating, my 2 S's in passphrase, but I don't have 3. And everything looks good. And at the same time, I'm also going to set no password. And that just disables any use of an 8-character password or fewer, depending on your password rules. Am I moving too quickly? Is everything okay with any questions so far?
No, your timing is perfect, Robin, and there's no questions.
Okay, thank you, Jamie. Okay, so this is just a screenshot of the WinSCP client, right? And it's just a really basic connection. I'm connecting to a nice private IP address there because I hope nobody has an FTP sitting on the front forward-facing ZOS system. I mean, it's possible, but perhaps not your strongest move. But notice that when I type in here, I'm typing in these 37 characters. And this is, I find it much easier. One of the disadvantages, of course, to a 37-character passphrase is it's extremely difficult to type that in, especially in a masked field. So one of the things that I found myself doing through this was I was cutting and pasting my password in there. Now, then, of course, you get into this argument of just how strong is it if I'm going with a 37-character password, but I have to cut and paste it because I have to write it down on a PC to paste it onto my field. So it's life on the razor's edge, I suppose. It's a choice between the devil and the deep blue sea. So there, I went ahead and did that, and I got success. Everything got logged on. Okay. So there you go. It's really simple, right? It's an unencrypted session. We can notice in the lower right corner that it's a gray key. So it's not encrypted. I'm just talking to a regular old port 21 server on this IP address. So passphrases are extremely easy. So that's something that we can go back to the auditors when they say, well, you can only do 8 characters, you know, in the mainframe for passwords. And they say, oh, no, if you want more than that for your FTP users, they have it right now. So let's talk a little bit about what it's going to take to set up FTPS. First thing that we're going to have to do is we're going to have to make sure that the communications server is configured to handle the TTLS. And this is through profile configuration statement. And that's because of the way that TTLS works. Transport layer is what actually enforces the security. Policy agent, which is what I mentioned here on the next line, is actually what configures the security policy into the stack. And the stack is what enforces the policy. Right? The TLS has the great advantage of transport layer security, the great advantage of it provides communication privacy over the internet, and it was specifically designed to prevent eavesdropping and tampering and message forgery with a relatively strong encryption algorithm. Now, the policy agent, the pagent, has to have read access to this serve auth resource that I've named here. And if it does not, it will get an RC4 and the pagent will fail. Socket request. And the init stack, and what that does is that allows policy agent to talk to the IP stack before initialization of the IP stack is complete, which is exactly what you would want the policy agent to do because it's going to be inserting policy into that stack. So it needs to talk. It's one of the few things that you really do want to touch this profile. It's a dangerous profile because things that potentially could initialize before the policy got in there could potentially circumvent your policy. Now, the policy agent configuration is outside the demonstration today. I'm not going to be telling you how to configure all your policies and those sorts of things. There's examples out there. I'm more than happy if you feel like reaching out. We can talk about that. Reach out to me on the side. But this is typically done through the IBM Configuration Assistant in ZOSMF, or you can manually code the statements into the ZOX Unix files and MVS datasets. And then the other thing that we're going to want to make sure that we have running is the syslog-d daemon. Right? That's going to be where all of our events gather for the telnet server, mail server, all the Unix system services stuff. They're going to be kind of running along there for FTP. Okay, so here's the configuration steps that we'll be performing through this. We're going to be implementing the ZOS components that we just discussed on the previous one. Now, because we're doing the policy agent, we're actually going to be specifying the handshake role and the key ring names the FTP server will be using in the policy. If you don't do that, you would be specifying it within the FTP data. For this demonstration, we're going to be using policy agent. And then we're going to have to do some server setup, right? We're going to have to do server certificate. Either you can RACF sign that, or you can have an external certificate authority sign it, and we're going to have to add that certificate to RACF as the certificate authority and the server certificate. As the FTP server, we'll bring those up, put them on the key ring, right? And that's so your server side communication works. So when we touch the FTP server, it will push back with a certificate for us, which we will accept. And then as we proceed through this configuration, you'll see where we configure the server to request a certificate from us. So once we've gone ahead and made some modifications to the FTP server configuration, we'll be ready to activate, and we'll recycle the server to activate those changes. So here you can see the command that I used to generate a test FTP server certificate. We're conducting this test on a non-standard port. I've stood up a test server for this purpose, so I don't disrupt my regular users. You can configure your system actually to do any or both of those. You can continue to serve over port 21, and, encrypt that. You can say no port 21, all encrypted only. Many ways to do it. Right, but I wanted to see here. Here's the actual command that shows the certificate sitting on the server, the key ring. So the certificate owner has to be the user ID of the FTP server. And that's so it has access to the private key. We're also going to connect the certificate authority that signed the server's certificate. And we're going to connect the certificate authority for the client certificate. So when that client certificate is presented to us, we're going to know who the signer is, and we're going to trust it. Remember, there's 3 conditions to trust a certificate. It has to be from a trusted authority, the date has to be valid, and the subject has to match what it is, either the server or typically not with the client side, but on the server we have to. So if we look into the FTP data configuration statements that we're going to need, here's the statements that will be required to activate the security for the FTPS server. We're saying go ahead and support all your TLS authentication extensions, and we're going to use the ATTLS mechanism. This is the preferred mechanism for implementation. You could use FTP as your alternative. And earlier I'd said the ATTLS causes the key ring keyword to be ignored, and we're going to use the pagent, and that's what we're seeing here. And then we're putting privacy controls on your control and your data connection, because FTP, I'm not going to get too much into detail, but FTP actually uses port 21 and port 20, because those are your two. It's actually one being the control plane, the other being the data plane. And so this encrypts both of those. So both all the control stuff, which is your commands, and the data, which is the actual packets, the actual payloads, everything will be encrypted. Right. And then we're going to say secure FTP required. And what this is going to say is only secure connections are allowed here. I will not permit non-encrypted connection. And this allows us to run the server port kind of with a dual brain, right? We can either encrypted or not encrypted. Now, for the purposes of this exercise, just because it's easier, we're actually going to be running explicit secure FTP. You're going to have to work with your network people on this if you decide to go ahead with the implicit, because then you're talking port 990, and we need to make sure that the network side is properly configured to allow, you to move through firewalls and those sorts of things. And then we've got statements that are associated with client logon, and how do we want the client to authenticate to us, right? Because that's really what we're talking about here, is we're talking about client authentication. Are you who you say you are? The default is no client auth. So basically, you don't have to provide any authentication outside of your password to say that you are who you say you are. But of course, the password can be acquired by unscrupulous individuals. If we say required, we are saying you must present us with a valid client certificate. Okay, and that basically means that the client certificate has to meet the conditions. It has to be trusted in the signer. It has to be a valid date. It has to be registered in RACF. So there's an additional check that we can put in here, and I won't show a great deal about it, but it's good to know that it's there. And this is a good control. This is verify user. And what this ties into is there is a serve-auth profile out there that allows authorization to the FTP ports based upon your user ID and whether you have read access to this resource. I've actually got a serve-auth presentation that's out on the RSH website, and it discusses in excruciating detail all of the horrible things that you can do with serve-auth. And I only say that, of course, tongue-in-cheek, because serve-auth is really important. You have to put I shouldn't say you have to. There are very strong reasons for you to want to put serve-auth profiles in place to help protect your system. It probably would have helped hacking scenarios, because again, the mainframe does get hacked. It's kind of a misconception that we live in a moat or that we're somehow isolated, and that these things happen to other platforms. So serve-auth is really good stuff. Like I say, I'd encourage you to go out to the RSH website and check out my presentation on it.
Robin, I think we'll definitely have you back to do a serve-auth session. It sounds, I've not seen it utilized to how it should be, let's put it that way, in some sites. It would be good to have a session on that. But we do actually have someone's raised a point on, Alexandro on the chat has said, we had an incident at IPL. TCP IP was not starting due to serve-auth class not being rack listed when we activated Pagent.
Yeah. Yeah, you're going to want that. That is true.
Okay, and then Carolyn.
That's a good pointer.
Yeah, yeah. And then Carolyn says, just a reminder, native TLS for FTP and Telnet 3270 is withdrawn in ZOS 2.5.
Yes, I believe you're correct. Yeah, I'm on a 2.4 system, so that's a good note to put in there.
Yeah. And Beth says, yes, please, a deeper dive on Surforth would be interesting. So you're booked, Robin.
Excellent. Well, that's good to know.
Okay.
Excellent. Well, and it's good to know people are paying attention.
Oh, they are, yes.
Excellent. Well, thank you. Okay, I'll continue. Okay, so we've taken care of the server side. Now we need to do some work for the client side. Right. One of the things that we need to do is we need to generate the client certificate with a private key. Now, I'm going to use RACF to generate the CSR, the certificate signing request. And you could use a third-party CSR. I mean, that could be provided to you. Maybe you've got, one group that says, oh, no, we do all the certificate signing requests, and it has to be done through this, and that's all fine. It doesn't matter. I'm just doing it through this way because it's much easier. And Simple Authority really doesn't have an easy way to generate a CSR that I found. So but RACF will do that all day long. So we use RACF for that. So we'll go ahead and we'll generate the CSR, and then we're going to send that off to the signer, and they'll sign it, and we'll take that signed copy back, and we'll put it back into RACF, which will complete the CSR and generate the private key. And then we're going to connect that to that client certificate authority to the keyring, which we saw previously. And one of the great things about this is you don't have to actually connect that client certificate to any key rings. It just has to exist in RACF. RACF must know the thumbprint of that certificate because that's what will actually get validated. And then we're going to take that signed certificate that we've now created on the mainframe, and we're going to take the P12 file, we're going to export it, we're going to put a copy down onto our workstation or server or whatever it is that you're running FTP client. Right, and we'll be setting it up with explicit encryption, and we're going to be using a non-default port just because we can. So the first thing that we're going to do is we're going to generate our certificate request, our certificate signing request. So as you can see here, I go ahead and I just fill it out with the information. I say, oh, it's going to be good for, let's say, a year. A lot of those things don't matter. Your policy folks will probably override that. In my animated of this, that's one of the things I showed was, I specified on my certificate signing request, I want a 10-year certificate. Well, they're not going to allow that at the certificate authority. They're going to go ahead and set their signing date to whatever they want to. So good field required for the GenCert command, not really going to be enforced. You'll be lucky to get what you back. And be sure to use a good key size on here, too. I should point that out, 2048. I mean, you can use less, you could use more. 2048 seems to be good, at least for now. And then we're going to export that out to a CSR file. And that's going to be a plain text file, right? It's going to look like every other CSR request out there. It's a begin new request, a bunch of base 64 stuff, and then an end certificate request. And so what we'll be doing is we'll be cutting that and pasting it. Now, you could do this with the transfer. I find that it's just easy just to cut and paste them. Put that into a text file. I send it off to my domain, network, security, gurus, whoever it is that signs my certificate, right? And then they'll send me a certificate back. I'm not showing all of that process because it's kind of outside the scope of this, and it's just not very entertaining to watch me move files around. So let's say that I got that file back from my authority, and they say, great, here's your signed certificate. I'm going to take that certificate. I'm going to binary upload it into a file that is variable blocked. I typically do VB84, LRECL 84, but the VB is kind of the important part. And then we're going to take that file that we've uploaded, and we're going to identify it to RACF. Right? And the moment that we do that add, that's actually what generates the private key. And then we're going to take that file that we've now generated, that certificate that now sits in RACF with this private key. I'm going to export it into a P12 file, and we're going to put a password on it. Now, that is password that's really, I've found platforms where the password to export a private key is not required. And I just can't understand how that would be considered secure. So as far as I know, RACF can only export a P12 file with the personal key, or the private key, I should say, with a password, which is good. So this password will be required, and do not forget this, because unlike a RACF password, this is a password that sits in that P12 file itself. And if you forget this password, this P12 file will be unusable, and you will have to go through this process again and regenerate it. It is unrecoverable. Right, so now that we're going to go ahead and we're just going to look out at the certificate itself just to see, is it actually what we think it is? So I'm looking at the P12 file. I'm looking at the file as it sits on disk. And I'm using the private key password notice. And I go out there and I say, so what do you got? And it says, yep, I've been signed by your simple authority CA, and here's your subject. It's Robin's test cert for the reg test user ID, and here's your algorithm. And we're going to be using it for handshaking. It's 2048, and you have the private key, so it's good. And notice it's not associated with any key rings, because that's not required. And so we put the PC, again, I'm not going to show you that step. It's a file transfer. We put it onto the workstation, server, whatever it is that your FTP client lives. And now we're going to go ahead and configure our FTP client to pick up that P12 file, which I've configured in here with my TLS settings. And I've said, okay, go out and pick that up. I'm looking at port 1073. With explicit encryption, as indicated on the kind of the right-ish panel there. And so now I'll be able to say OK and have it go out and do its thing. And it's going to say, well, I need a keyword passphrase, that PVT password that I put in previously. Now notice I'd used this ID previously to connect, right? And I don't need the 37-character horrendous passphrase, right? Just my simple PVT key PW. And I go ahead and I connect. And look at that. So we notice in the lower right corner, the gold key is now active, right? And we see a directory and all this. So I am now connected using secured FTP with no password client authentication to the ZOS FTP server. So the next time your auditors or some, the Windows people or the Unix people come, knocking at your door, disparaging our system, telling us it can't do the things that we need it to do, like all the grown-up systems, we can say, no, FTP, we can do all of that stuff. And as we'll talk about here, we can actually do a little bit more. Now, whether that's a good thing or not, I don't know. We'll see. That's up to you, I suppose. But just to summarize what we've talked about here with FTP-S, right? This is a unique protocol from SFTP. We're going to want to make sure that our ZOS server components are in place, right? Our profile statements, our policy agents, our syslog daemon. We're going to want to make sure that our FTP data is configured properly for TLS activation and for client authentication. We're going to make sure our TLS port is set properly. 0 in this instance to disable the implicit secure FTP. And we're going to use, explicit might be what you run at your shop. Might be running implicit. Don't know. You have to work with your network people. I know it's freaky, but it's good because it's communication. Everybody learns. And FTP-S will run on the port that it's defined at the server startup. So if you want to change that, you're going to have to bounce the server. And you're going to want to make sure that you use a client that actually talks the encryption standard that you're going to be using. We're going to be creating a client certificate. We created, I should say, a client certificate with the user ID That user ID is the certificate owner. And then we use a passphrase to access that private key. And actually, that's kind of an interesting passphrase, given the previous one. Isn't it great to edit these in real time? So password, or we'll call it a passphrase, but it's actually an encryption passphrase. It's not the passphrase in the RACF password phrase that we talked about earlier. And I'll provide that clarification on the PDF, because there will be a PDF made available for you to look over this. So don't feel like, oh God, I have all this stuff and it just blew right past you, you didn't see it. There is a PDF that is available. It's on our website. I'll provide a copy to Jamie if you'd like, and you can put that up on the GSE site or wherever. So the other thing that I kind of wanted to talk about was the FTP Jazz Interface. This is a unique feature, I guess we can say, to FTP on ZOS. FTP is a data transfer product. It's really not intended to be able to submit jobs and retrieve output from the Jazz spool, at least in the RFC standpoint. But IBM decided that this would be of value to the customers. And I have seen this in the wild. This actually does exist in customer shops. They are running jobs from FTP. Now, this isn't new, right? It's not like all of a sudden in the year 2017 or 2021 or within the past 4 or 5 years, we said, oh my God, we can do Jazz spool from FTP. We've done this for quite some time. And in fact, Bob did a really nice job about 11 years ago now, holy cow, of just kind of writing up things that you might want to consider to protect your Jazz spool from FTP users. Because remember, a lot of people can be FTP users. Right? You're going to carefully consider your Jazz interface level. Jazz interface level 2 will allow an FTP user to read the entire spool. And I have seen this at shops. Some shops out there do run Jazz interface level 2. Extremely dangerous. But this Jazz interface, because I have access to the spool, I can run TSO commands, I can run Rex programs, I can issue system commands, I can do all sorts of crazy stuff because I can touch the spool. Now, for the purposes of what I'm going to show, WinSCP doesn't like it. Jazz just doesn't deal with WinSCP, or I should say WinSCP doesn't deal with Jazz well. WinSCP is looking for file types, file names, those sorts of things. And those concepts really don't exist in Jazz, right? We deal with job names and output and numbers and those sorts of things. So WinSCP doesn't quite know. But the Windows FTP client, it's easy. So that's what we're going to be using. And I'm just going to show you here what that looks like. So let's say we go ahead and, just from my desktop there, we'll go ahead and FTP into that system. Nice unencrypted connection, right? I used my passphrase. I used a password because, remember, I can't enter blanks here. So I did a little behind the scenes setup of this. And I went ahead and I said, oh, go ahead and put me in the temp directory. And then I'm going to put out IPL info, which is a really nifty little Rex program, easily available. And it'll tell you all sorts of good stuff about your system. And I said, great, go ahead and put that into my temp directory. And then I'm going to change mod to make sure that I can execute it. And I'm going to say, great, now I'm going to put a batch job up there. I'm not showing you the text of these batch jobs, but you can figure it out from what I'm doing here. All right, I'm going to put the batch job up there that says, go ahead and run that script that I just uploaded into your temp directory. It says, okay, so here's your job. And so now I can go ahead and I say, get that job back. And now I actually see from that job all the IPL info. I didn't provide that slide here. I don't own IPL info. I'm not going to show you the output from it. But IPL info is available on many, many systems. In fact, I think it's even screwed into the framework of ZOS at this point. And I mentioned Jazz Interface Level 2 and how dangerous it is. So if I've got Jazz Interface Level 2, that I can go out there and do a couple quotes commands, set Jazz owner to everyone, set Jazz job name to everyone. I say quote stat, and I got a whole list of options. And hey, look at that, my Jazz interface level is 2. Great. I say mget, get me the spool. And if I was to go out at each of these different FTPs and see what they were downloading, as they pulled them down, I would find everything on the spool. I'd find started task output, I'd find job output, I'd find basically anything out there. And this might not be stuff that you want just the average person to get out and see. So what can we do about that? How can we stop people from doing that? Well, you have an option. You can code a user exit, right? That's not necessarily the easiest thing. You have to know assembler, how to put the program together. But I've coded a program just out there. It says, go ahead and do the command check, and I'm going to make sure that you're not issuing Jazz commands. So you can't actually get into the Jazz subsystem from FTP. And I might put any number of parameters within that check. I might say, oh, certain groups can, certain groups can't, only certain commands or subparameters, or any number of things can be issued. It's very customizable. And then you put this exit into an APF library, you'd bounce your server, and then what you'd see, whoops, wrong direction, sorry about that, is I'd log back into the server, right? And I'd say, great, go ahead and drop me into Jazz. And it'd come back and it'd say, oh, hey, user exit. No, can't do that. Installation exit will not allow you to use that site command. I say, no, I need to use Jazz. I say, no, you can't do that. Okay, what if I use an abbreviation of it? No, I still can't do it. Okay, fine, I need to use SQL. Oh yeah, you can still do that, which you might or might not. And then sequential, right? And that's the default mode. Right? That shows what it is. But as you can see, I mean, that's a user exit, which might or might not be easy for you to code. One of the things that RSH has proposed to IBM through an RFE is we would like to see a Jazz interface level 0 parameter introduced into FTP data. And what this would allow you to do is make a call to a SAF protected resource that can restrict job submission and sysat retrieval for FTP. So for those installations that use it, because again, I have seen this in reality, they would have an avenue to be able to continue to use that, but we'd gain some control over it. Because remember, depending on how you're auto-assigning your UIDs and your OMVS segments, you might have a CICS user out there that has no intention of getting into FTP. But if they can connect, get an auto UID assigned, now they're on FTP. Now they can get all your IPL info. Hope you're locking down your RACF database. Because if they can get read access to that, they can take that. I've actually got another really good presentation. I actually talk about Gottfried's hack of Logica. It was extremely impressive. But if you go to the RSH website, we have an article out there that talks about the RFEs and how you can vote for this. I highly encourage you to go out there and give it some foot traffic. That'd be great, because we really feel that this is an important enhancement that needs to be made to the FTP security. And that's my presentation.
Thank you, Robin. I think we've got a couple of questions actually in the chat. So Lenny, I don't know if you want to unmute your line. It's something about certificates.
Yeah. Hi, Robin. So I'm trying to understand, when you're downloading the P12 file down to your Windows client, you download the P12 has both the private key and the certificate. And I'm normally, as a client, you wouldn't be using a private key coming in. So I'm slightly confused as to why you need both those there. But I'm wondering if it's simply to map to the identification. But anyway, perhaps you'd talk about that.
Yeah, sure. Well, remember, this is the client private key, right? This is a private key associated with a client certificate. So this is a key that is possessed by one and only one user ID. And so that private key, when I'm talking about you put it out onto the client,
Okay.
pardon me.
Okay.
Okay, when you put that client out, we'd never do like the certificate authority or the server or any of those private keys, because
yes,
each of those.
Yes, maybe I missed a step earlier on, but I saw that happening and I thought I'm confused. So you're saying essentially
server private key would be devastating.
Right. Yes. So the certificate and its private key that is downloaded is essentially acting as the identification for the client coming in.
Correct.
Right. So the fact that you have to put in this password is simply to unlock that that encrypted file at the point where you do the authentication. And of course that doesn't flow on the link. It simply flows to your from your keyboard to your client.
Right. I mean, you could handle that programmatically, right? Where if I had a script out there, but and this would be like equivalent to like a PFX file, in the Windows world, right? Where I actually have a password protected file, and that's what the password's protecting. And so if I were to port that around to a Linux box, then I would have, if I was writing Python scripts, then I would have an operand that said, here's my private key, or my private certificate, my password to pick up my private key, because it would all be packaged. Yeah, certificates are kind of an interesting construct in the P12s, because unlike PEM formats or other formats that you'd see, like with open systems, the private key and the certificate are all accumulated in the same file.
Yes,
right?
that was.
I don't have a
crux of my query in the first place, but I think I understand.
Right.
Now. Thank you for your explanation.
Oh, certainly.
I'll go back on mute, Jane.
Okay, thanks, Lenny. Philip, I saw you had a point that you made in the chat. I don't know if you want to unmute your line. There was a very good point you made about.
Oh, right. I just meant that if you want to avoid being prompted for password and want to use a client certificate, and the ID should be mapped to a RACF user ID, then it is recommended to specify the keyword secure_password optional in ftp.data.
Mm.
This is just to avoid being prompted for password.
Okay, thank you.
And also the thing around the serve out is not something which is required, depending on which they call it level 1, level 2, level 3. So by default, if this is just to make sure that the client will be mapped to a RACF user ID, but the control against the served class is only in case the class has been activated on your system. Then in that case, not only the client certificate has to map to a RACF user ID, but in addition to that, as Robin has mentioned, there will be also a check against the served class of RACF.
Right, but and there is no requirement that serve-off be active.
Yes, correct.
Right. I mean, it'd be a poor practice. I certainly wouldn't recommend. I would like to see everybody activate serve-off, but you're correct. There is no requirement for that.
Thank you, Philip.
Thank you.
Anybody else? Any other questions? Do feel free to unmute your line. We won't bite, honestly.
Hi.
Hi.
I just want to clarify something. And in fact, using FTP as clients, we are making, there are two processes involved. One is the handshake process, and the other one is the mapping. So after the handshake process success, then we will use the certificate to map to a RACF user ID. and that is why the certificate is in RegF. In Robin's presentation, you can see the reg user act. That step there, that is actually adding the certificate to RegF. If you don't add that, then even the handshake works. It cannot proceed to map to a user ID. And the way that Robin did this is she generate the client certificate in RegF. So that's why the private, when you add, right, and you are combining the private key when you generate a CSR and combine it into a with the certificate. So it end up in the RegF database, you have the private key also, but it is not needed. You don't need a private key to be the private key of the client certificate in RegF. You just need the certificate, right? But since you did it that way, that is a byproduct that you can get the private key too, but it is not needed. And think about that, the two party, for the ZOS side, we have a RegF keyring, right? That is the server side, and your Windows box is in fact another keyring. You can think of it as a keyring. So it's just two party. The keyring is in the Windows box. The keyring is in the in ZOS. And when you add the package PKZ12 in your Windows box, that is where you can consider that it is a keyring that contains the client's private key. So you think of that way, that will make it clear, right? And I don't need the client's private key in my server side. So don't confuse these two concepts. Although the example you give is kind of, oh, you have the private key also in RegF, but that is not the important.
Just because I did, yeah. Oh, you're right. You're right. Yeah, I could actually show. I guess what I was trying to demonstrate on this slide was that the private key is sitting within the P12 file.
Right. Yeah.
Right. So
right.
in what's going to be transferred, and that's what I was trying to demonstrate here.
Right. Right. Yeah. But we don't really need the private key. Yeah.
You're right. You're absolutely correct, and I can clarify.
Mm-hmm. And most people got confused is because we are not clear. There are two parties, so you have to very very careful on which party we're talking about, which keyring we are talking about, right? And there's only one keyring in ZOS in your scenario. That's the server's keyring, right? We don't have right. We don't touch the client keyring at all because the client keyring is on Windows, right?
Unless we were to be the client, right? If I were acting as a client to another ZOS server, then I would have that client certificate in the same way that I show it here, as being the client is a Windows system. Oh, as a ZOS system, then it would be on my keyring.
Right. So people may get confused.
Behaves as the client, then you could use virtual keyrings.
No, if you want to use client authentication.
If FTP server on the OS is the client, then you can use virtual keyrings. You don't need to have every single ZOS user to have its own keyring for that purpose.
I have to double check that.
FTP client is on the OS, you can use virtual keyrings. You see what I mean? If
I have access, I'll go ahead.
If you issue the FTP command from OMBS or whatever, so the FTP resides on ZOS, the FTP client is on ZOS, then you can use virtual keyrings.
Yes.
Not every user needs to have a keyring for that purpose.
That is truth. You can use a virtual keyring and have those sitting in kind of in the same way that SMPE is delivered, right? In the same, and if you have systems folks, they know what I'm talking about, right? SMPE is currently delivered by, in essence, a shared private key, which isn't truly what you're doing here, but I get your point.
Philip, have you tried it?
Right.
Yeah, sure.
Okay.
Yeah, and that isn't something that I set up for this demonstration. The point of this demonstration was to just kind of take the simplest line through things, but certainly a great deal more complexity could be added. You know, virtual keyrings would be one of them. I did not use virtual keyrings. Okay. I use a one-to-one ownership.
Okay, thank you, Philip. Thank you, Y. And nice to have you back, Y, with us. You just reminded me I've got you're on my list to book you for another PKI session for an upcoming GSE meeting. So any more questions? I actually do feel free to pop them in the chat, by the way, folks, but I have a question for you, Robin. So on the topic of password phrases, in your experience, are organizations using them more than
almost none?
Almost none. Okay.
Yeah, most organizations that I see are still married to that 8-character password. One of the things that I'm really hoping to see in the future will be kind of a widespread adoption of multi-factor authentication, because that, I mean, really lends itself to passwords very well, because if you have an 8-character password and a 4- or 6-character token, well, you're naturally going to be into a passphrase at that point. And so I think as that gets adopted more widely, which I hope will be, you know, a trend of the industry, I'm thinking that passphrase usage on ZOS will increase. But I'm not seeing it widespread right now. Most people aren't. Most people are. I'm still seeing folks that are honestly interested in getting mixed and special case working, and I'm trying to convince them, some of these clients, to say there's a lot more value to be had from increasing your password length and your encryption algorithm. Consider turning on KDF-AES and activating passphrases as you know, continuing to pursue an 8-character passphrase with a mix, because as you know, it's a pretty limited set.
Yeah, and I've just launched a poll, actually. I don't know if you can see it, for everybody to complete around, just to kind of get an idea of who's using passphrase. Well, the kind of percentage of the population that are using password phrases. So do feel free to complete that, folks. This is anonymous, by the way. We're not collecting any personal details here. It's just a kind of an interesting statistics to see what's going on right now. So it's creeping up, Robin. We've got 33 responded, and it looks like the majority so far are not using password phrases, and that aligns with, of course, what you just said.
That's, you know, and of course that can vary, right? Depends on the audience you're talking to, but this, just generally, I'd say that's more dull. I mean, on the plus side, most people are at least insistent on 8-character passwords, right? Because RACF, you know, as you know, you can dial that all the way down to a 1-character password. And I do at least see 8 characters consistent. I see some pretty bonkers patterns out there that are rather infuriating, both from a security and from a user standpoint. But yeah, I think multi-factor is probably the single biggest thing. That and KDF-AES. Yeah, the two things that probably increase security most of all. It would have prevented Logica.
Indeed. And I see, thank you, Philip, for your point. You said that it's becoming a requirement in IBM internal systems nowadays. So that's good. That's good. So I'll just send you, everybody, the results of the polling. I'll close the poll now, and then you can see the outcome of that. So yeah, 77% of you have said that basically you're not using password phrases. But it's, anyway, it's just like interesting to see what's going on there. But Robin, thank you so much for taking us through that session. It was really good. And like I said, I think we've already got you booked in for a ServAuth presentation later this year for our next GSE meeting.
Yeah, looking forward to it.
So thank you very much. Okay.
Thank you.
Thank you. So up now, everybody, we have a 15-minute break. And we're going to switch over to our next session at 3:30, which is around mainframe passwords revisited. And that's going to be a panel. And I think some of our presenters are already entering the meeting. So we'll get ready for that. So enjoy coffee break, tea break, and we'll see you in 15 minutes. Thank you.